Hi guys, this is Prashun again. Today we will discuss about the addition, subtraction and multiplication of matrices. In my previous lecture we have gone through the different kinds of matrices, what is a matrix and what are the different types of matrices, and here we will discuss about how to do addition of two matrices, how to go for the subtraction and how to go for the multiplication. Let's see. Let's proceed and how let us see how we can do these things. Okay, so first let us go through the addition. Matrix addition is possible only if the order of the given matrices are equal. So let's say there are two matrices of 2 cross 2 matrix, then the addition is possible. There are two matrices which are 3 cross 3 matrices, then the addition is also possible. There are two matrices where the order is 4 cross 4 matrix, then also the addition is possible. So now we will go through example and we will see how to do the addition. In your joint tender syllabus, basically we are going through maximum 3 cross 3 matrices. That is good basically. So we won't discuss anything beyond 3 cross 3 matrices. Okay. So let's say in our example we have taken two matrices, one is A, one is B. The A terms of A are different elements of A are A11, A12, A21 and A22, and different terms of B are B11, B12, B21 and B22. If we do addition, then how the addition happens? The addition takes place in such a way that is the same types of elements are added together. That is A11 is added with B11. A12 is added with B12. A21 is added with B21. A22 is added with B22. So this is the resultant matrix. A plus B equal to A11 plus B11, A12 plus B12, A21 plus B21 plus and another one is A22 plus B22. So this is how the addition takes place. So you can understand like why the order of the matrices are equal. If the order of the matrices were not equal, then these types of addition was not possible. Like let's say there is a term A31, but A31 we cannot be, this cannot be added to any terms in the with the B because there is no B31. So that is the reason the addition is not taking place. Okay, now we will go through subtraction. Subtraction is also possible if the order of the given matrices are equal. Subtraction is will go with the same way of addition, just the sign will be negative, that's it. So here also we have taken the same two matrices A and B. The elements are also same like A11, A12, A21 and A22, and in case of B it is B11, B12, B21 and B22. So when we will subtract B from A, at that time my elements will be A11 minus B11, A12 minus B12, A21 minus B21 and A22 minus B22. So that is the way the subtraction we have written. Hope this is clear. Now we will go through the matrix. Multiplication of matrix is a little bit tricky, and you have to remember the each and every step because it is nothing very simple. Multiplication of matrices can be done for two purposes. One is multiplication of matrices with a scalar, and another one multiplication of matrices with another matrix. Basically two matrices will be multiplied together. So here also different rules are there. What is the rule? The matrices can be multiplied if number of column of first matrix equal to the number of rows of second matrix. It here not the same order of matrix, right? 2 cross 2 matrix can only be multiplied with a 2 cross 2 matrix. That type of formula is not there, which was there in case of addition or subtraction. Here are different types of rule is there. Matrices can be multiplied if number of column of first matrix equal to the number of rows of second matrix. Below we will discuss the process of multiplication of a 2 cross 2 matrices. So let's say here, though we have taken here same order matrices, one is for the simplicity, A equal to A11, A12, A21 and A22, and B equal to B11, B12, B21 and B22. So let's see how the multiplication takes place. Multiplication takes place with the row multiplied with column. How? Let's take the example. Let's say for A, the first row is A11 and A12. Okay, first column is B. For the second matrix, first column is B11 and B21. So what it will do? It will first multiply A11 with B11, then A12 with B21. Okay, so this is coming my first element of the resultant matrices. So that is this one. Second case, first row will be multiplied with second column. So A11 will multiplied with B12 and A12 will multiply with B22. So that will be coming as my second element. For third element, how? I will take the second row and first column. Second row means A21 B11 plus A22 B21. And fourth element, how? The second row with second column. So A21 B12 A22 plus B22. These things you have to remember. Here the rows are multiplied with the columns. If we have a matrix A which has a dimension of, that is order, of 2 cross 3 and a matrix B which has a dimension of 3 cross 4, then the resultant matrix after multiplying A and B will have the dimension of 2 cross 4, that is number of rows of the matrix A into number of columns of matrix B. Earlier case I have already discussed, if a number of column of first matrix equals to the number of rows of second matrix. So here if you see the A matrix, it is having 3 as a number of column, and for the second matrix 3 is a number of rows. So my first condition is satisfied. So both are 3 and 3, so the multiplication is possible. So if I negate 3 and 3, my resultant matrix will be 2 cross 4. So that is the rule of matrix. So these two negate each other, the first matrix column number of columns and second matrix number of rows. So this will negate each other, but this is the rule of multiplication, and the resultant matrix will be these 2 and these 4. So 2 rows and 4 columns. When we multiply a scalar with a matrix, then the result will be a matrix obtained by multiplying a scalar to each element in the matrix. That's it. Like the scalar, like 5 if I multiply, or 6 if I multiply with the matrix, then it will be 5 into each and every element, 6 into each and every element. So that is the way scalar multiplication takes place. Now there are few properties of matrix multiplication. Why? What are those? Multiplication of matrices does not satisfy the commutative property, that is the example I will show later. If A and B are both n cross n matrices, then the determinant of their product is independent of the order of matrices in the resultant product. Like date of AB, determinant, if we calculate for matrix multiplication like A matrix and B matrix multiplied by together, the determinant is equal to if we multiply B matrix and A matrix, both are same. If both matrices are diagonal square matrix having same dimension, then their product is always commutative. Only if they are diagonal square matrix, then only the product is commutative, else the product is not commutative. Commutative means A cross B not equal to B cross A. If A dot B equal to B dot A, then it would have been commutative. Here it is not, so that is the reason it is saying commutative, not commutative. Okay. So let's move. Few more properties. Matrix multiplication satisfy the associative property. That is, if PQ into R, PQ all are different matrices, if PQ into R equal to P of P multiplied with QR. Multiplication of matrices is distributive over matrix addition, that is A multiplied with B plus C, then it is AB plus BC. AB plus AC, it will be AB plus AC. It is wrong. There is a printing mistake over here. Scalar multiplication of matrix, if C is getting multiplied with AB, then CAB or AC is the scalar. So AC into B, that is A of CB, or AB into C, that is A of BC. All these things are equal. How to now the major thing is how to multiply matrices. So we will see how we are doing these things in a real time example. When we multiply two matrices, the number of column of the first matrices should be equal to the number of rows of the second matrix. This is a common rule that we have discussed already. So let A be a matrix of order m cross n, okay, and B be a matrix of order n cross p. Here we can see for the A matrix, the column number of column is equal to the number of rows of the second matrix. So this satisfies. So n cross n, if I negate each other, then the resultant matrix will be m cross p. Product of the matrices A and B is of order m cross p. That is fine. Now let us go to a typical example of a 2 cross 2 multiplication. So A is one matrix, that is 2, 5, 1 and 7, and B is another matrix, that is 3, 2, 7 and 1. So step 1, multiply the elements of the first row of A by the corresponding element of the first column of B and add the products to get the first element of the first row of AB. How we are doing these things? Let's say A and B we have taken. Now first row is 2, 5 of the first matrices. First column is 3 and 7 of the second matrices. Now it will be 2 into 3 plus 5 into 7. So 2 into 3 is 6 plus 5 into 7 is 35. The rest of the things we still don't know. So 6 plus 35 equal to 41. So 41 I am writing over here. Step 2. Multiply the elements of the first row of A by the corresponding elements of the second column of B and add the products to get the second element of the first row of AB. How? A and B again we have taken. I am taking first row of matrix A and second column of matrix B. So it will be, you see, 2 into 2 plus 5 into 1. So 2 into 2 4 and 5 into 1 is 5. So it will be my second element. Second element is 9. The rest of the elements I don't know. Let's go to step 3. Multiply the elements of second row of A by corresponding elements of the first column of B and the products to get the first element of the second row of AB. So again I have taken the same matrices. Here I am taking, for the first matrices I am taking the second row, and for the second matrix I am taking the first column. So it will be 1 into 3 plus 7 into 7, that is 3 plus 49, that becomes 52. Rest of the elements I don't care. Step 4. Multiply the elements of the second row of A by corresponding elements of the second column of B and add the products to get the first element of the second row of AB. So how? A and B again we have taken. I am taking the second row of the first matrices and second column of the second matrices. So now the product becomes 1 into 2 plus 7 into 1. That means 2 plus 7, that becomes 9. So my all the four elements, this is the way how the multiplication is done. Now there is a simple thing, that is scalar multiplication. If scalar product of a real number m and a matrix is A, then the resultant is m into A. Each element of matrix MA is m times its corresponding elements, but order of the matrix is remain the same of A. If A is a matrix of order m cross n and is a scalar, then the matrix Ka is obtained by multiplying each elements of the matrix A by K. So how? Let's say the matrix is A and the elements are A11, A12, A21 and A22. If I multiply with K the matrix, then it becomes Ka1, Ka21, Ka12 and Ka22. This is how the scalar multiplication takes place. So till now I have discussed only the 2 cross 2 matrix. For the 3 cross 3 matrix, just the rules will be a little bit difficult because it will take another row and another column. So I have taken 2 matrices A11, A12, A13, A21, A22, A23 and A31, A32 and A33. This is my first matrix of 3 cross 3 order. The second matrix I have taken B11, B12, B13, B21, B22, B23 and B31, B32 and B33. So my now resultant matrix will be A11 into B11, A12 into B21, A13 into B31. You just see first row multiplied with first column. So my first element is coming. For the second element, first row multiplied with second column. So how? A11 into B12, A12 into B22 and A13 into B32. How the third element will come? So the first row and third column. A11 into B13, A12 into B23, A13 into B33. So you can see the third element is coming. Similarly, second row and first column. A21 into B11, A22 into B21, A23 into B31. In this way, the this column is coming. This element is coming. So this is the way how we are doing 3 cross 3 matrix multiplication. Hope this is clear. So that's all about addition, subtraction and multiplication of matrices. Next chapter we will go through the determinants and how to find out the inverse of a matrices, cofactor and different terminology. Transpose of a matrix also we will go through. So that's all. Thank you for watching my video. If you like, please like in the YouTube or subscribe me so that this video can be reached to wider audience. Have a good day and thank you.